Hey guys, welcome back. I picked this example to show you guys to make a video on because it encompasses a lot of different topics that we've talked about this year. It talks about setting up a system of equations. It talks about all the probabilities summing to be 1, as well as the expected value rule that we just learned. So for the first part, we are given this probability distribution table. And they give us that the expected value is 1.7. Now, like I always try to get lost in thought about what this probability distribution table might represent. Don't do that because we don't know what these x values represent, especially that there's a negative value. So don't try to get lost, just follow your principles. And specifically, AICE does this because they want you to slow down on that part. So they're testing to see, do you know the rule for expected value? And you do. So we know that the expected value of a discrete random variable x is equal to the sum of the x values times their corresponding probabilities. Okay, so by using this definition, all you have to do is plug in all your values. So 1.7 would go here for your expected value, and then we would do the sum of each x value times their corresponding probability. So when you do that, this just takes a little bit of time to set up. I like to use parentheses to do this, to isolate each individual x value, but you can do this however you wish. Now here's the part where we're going to have a couple variables in our equation. And typically what you guys are going to notice for a straightforward question, you would just type all of these in your calculator and just kind of go away. But since we do have variables, we have a variable right here and we have a variable right here. A couple of things need to start turning in your head. First and foremost, they're two different variables. I have P and I have Q. So anytime in algebra, when you guys have two different variables, you need two equations to solve them. Okay, so I'm going to go ahead and work with this equation that I have. And when you simplify everything, this is going to come out to be, let me back up a second so I don't skip too many things. You have P plus 0.3 plus 4Q. Okay, and what I like to do when I am setting up a system of equations, I like to keep my two variables on one side of an equation and get all of my numerical values to the other side. So when I move the negative 0.4 and the 0.3 over to the other side, it ends up being 1.8 on this side. And then I have my P plus 4Q here. And I'm going to kind of keep this isolated for a second, okay, and save that. So now is when you guys have to start thinking about what other type of equation can I use that's going to incorporate this P and this Q. And having a little bit of background with probability, we know that probabilities all add up to be 1. Okay, so the probability for a certain event adds up to 1. So what we're going to do is create an equation for that. So if I add up all of those values in the probability row, I come up with this equation. And what I want to do, I'm going to simplify this the exact same way I did the last one. I'm going to just add up my values first before I start moving anything. Actually, I'm just going to go ahead and move everything, sorry. So I have P plus Q is equal to 0.6. And I'm doing that because I'm running out of room over here. So if you take these two equations and you put them together, whoosh, whoosh, there's a little sound effect for you. And notice that in this one, my P and my Q are kind of on the right side, so I'm going to reverse that. So I'm going to have P plus for Q equals 1.8, and then I'll have P plus Q is equal to 0.6. Now you guys can solve this any way you want. It's a straightforward system of equations. The easiest way I would do it is if you look here, your P's have both the same leading coefficient, so you could easily subtract them. To me, that would probably be the best method. So if you subtracted these two equations, those P's cancel out, and then you would be left with 3Q is equal to 1.2, and then divide by 3, and you get Q is equal to 0.4. And if you were to plug that value back into either one of these equations, it doesn't matter. I think this bottom one's a little bit easier. When you do, you get the value P is equal to 0.2. Now keep in mind, these are your probabilities that are going to go back into this table. So this is an AICE question that keeps going. That was part 1. Let's go ahead to part 2, which is to find the variance of X. So in the lesson, we have a formula for variance, and our variance formula is the same variance formula. It just has a different like title, what we call it. Before we used the little sigma notations like this, whoops, kind of like that, right? Where we would use that for variance. But for this one, it's just easy to use. It's var x, but really it represents variance. And that notation is easier to use here because every question is going to ask that of you. And so just kind of getting used to the notation is helpful. So the more you write it, the more you understand it. Now your formula is going to be representative of the sum of the squares times the probability minus the square of your mean, right? And that's what this expected value represents. So if you do that, we have to go back to the table here. So when you see this sum, this part right here, this is the sum of all of the X values in my table squared times their probability. So it's almost going to be the exact same as this step right here, except I'm going to square all my X values. So you kind of have to do a little bit of scrolling here, and on an AICE exam, this would all be on the same page. So if I plug everything in here, this is going to look like this. My first X value is negative, so I use parentheses anytime I square a negative value, because if I don't, my calculator is going to give me an incorrect value. And that, to me, is also an indicator of why AICE put a negative value here, to catch those people. And then you just kind of plug away, put all these in here. All of your X values squared. I'm running out of room. 4. And then minus this value squared, okay? Now, we already found our expected value, or we didn't find it, we were given it, and our expected value is given to us to be 1.7. So we just take that value and we plug it down here, and we square it. So minus 1.7 squared. So you have a couple options here. You can plug this all into your calculator. To me, that's a little much. So what I do is I do maybe each individual piece, like maybe I'll plug this in, and then I'll plug that in, and so forth. Or if you want to kind of go for it, you can plug in maybe this whole first part, get an answer, and then plug in this second part and subtract the two. However you guys want to do it, I'll leave that up to you. But to kind of keep this video short, once you plug all those values in, this is your variance. And you round this to 3 significant figures, but the key when you're finding variance is you don't round too soon. If you round too soon, then your final answer might be incorrect. So keep every value with their original decimal places until that very last step when you get your answer. Now, if this question asked you to find the standard deviation, let's say, of X, then all you would have to do is take the square root of 5.41, and then that would be your standard deviation. So if ever asked about that, that's how you would find it. I hope that helps.